All right, so now we are looking on the reactions of esters. So we'll talk about esters. Esters are sweet smelling. Esters of low molecular formula are generally sweet smelling, right? And they are not so soluble in water. All right, so those are esters. Ester functional group is COO or C double bond O, or it could be even written the other way, which is O C double bond O, same thing. So anytime we see this in a molecule or this in a molecule attached to some alcohol, that's the ester, right? So these are ester. Now we're going to be talking about what happens when an ester is formed. So when an ester is formed, so in order to form the C double bond O, right, the molecule is joined here. The molecule is joined here. This end of the ester comes from the acid, and this end of the ester comes from the alkanol. So when esters react, they're going to react right at this point right here. So when esters react here. Before we get into the reactions of ester, we're going to draw some esters. So without doing the reaction, we're going to draw ester. So the first ester I want to draw is propyl propanoate. The propanoate comes from which part? The acid or the alcohol? Propanoate comes from propanoic acid, so I'm going to draw that. Propanoic acid have 3 carbons. The acid lost the OH, so I'm not putting the OH there. The ethyl comes from ethanol. The ethanol loses the H. So this comes from the ethanol. This comes from the ethanoate, from the propanol, sorry. So I'm going to draw methyl methanoate. Methanoate comes from methanoic acid, which has 1 carbon. I don't put the OH on the acid because in the ester formation that is removed. Methanol, methyl comes from methanol, which has lost a the H. So this acid would have lost the OH and the alcohol would have lost the H to form these esters. If you're confused, go and watch the ester formation video. So now we're gonna draw methyl butanoate. So draw the butanoate part first. 4 carbons. We don't put on the OH. Then I'm going to draw the methyl part, which is O, has 1 carbon, which is H. One carbon, which is C. So this is methyl butanoate. Clear? Now, ester undergo hydrolysis. We have 2 types of hydrolysis. We're going to be looking on acid hydrolysis first. In acid hydrolysis, the ester is boiled in dilute hydrochloric acid and or H2SO4. The dilute acid provides water molecule. So in esterification, in acid hydrolysis of ester, between the two O's, the carbon that has the two O, we're going to break the carbon between the C and the O. So the molecule is going to break. So in acid hydrolysis, we're really reacting an ester with water. When the ester reacts with water, to the acid part, I'm going to add OH. And where the O is, we're going to add H. So what I'm going to end up with is the acid part is right here where the C double bond O is. To that part, I'm going to add OH. And to the alcohol part, I am going to add H. So this is what I end up with. Clear?
Yes, miss.
So during acid hydrolysis, I form back the ester, the alcohol, and the acid, which forms the ester. So during acid hydrolysis, in the presence of dilute acid and heat, the ester can be converted to ethanol and ethanoic acid, which formed it, right? So here I have an ester, which is ethyl propanoate. Propanoate has 3 carbons. Ethyl comes from my alcohol. It has 2 carbons. Comes from my alcohol. When I add water, my molecule is going to break right here. And to this portion, I'm going to add OH, and to here I add H. So what I'm left with is H. C double bond. And then I add back my OH here. Plus my alcohol. So I form back my propanoic acid. And my ethanol. Good?
Yes, miss.
Miss Walker, so we're doing the same reaction, ethyl propanoate. Propanoates have C2H5, propanoic acid COOH. The OH goes ethyl O C 2H5. The molecule is split between the OH, the two O's. When it's split between the two O's, so the acid part, which is the first part, we're going to add OH. And to the alcohol part, I missed out the water. To the alcohol part, we're going to add H, so we'll do C2H5OH. So put it back, like how the alcohol is written. Clear? So in this reaction, we're going to acid hydrolyze propyl ethanoate. So we're going to do the molecular formula first. So the molecular formula ethanoate comes first, which is CH3COOH, but to form the acid, the OH went, so we're not going to put that. And then we have O from the propanol, and then propanol is C3H7. So when we add water to it, notice the arrow is different. In the acid hydrolysis, we use a solid arrow. We're going to split the molecule between here to the acid part, which is the first part. We're going to add OH. And to the second part, we write back the C3H7 and we add the H right there. When we draw it now, propyl ethanoate has 2 carbon. And we have C. Am I going too fast? No. Split the molecule right here. When I split the molecule right here, I'm left with CH3 C double bond. Where the double bond, what do I add to this part of it? Add a OH. And to the alcohol part, I add a H. So that's what I get when I acid hydrolyze this. So we're moving on to another type of reactions of ester, and this is another type of hydrolysis, which is called alkaline hydrolysis. So in alkaline hydrolysis, the ester is reacting with an alkali, for example, sodium hydroxide and potassium hydroxide. Now, sodium hydroxide is NaOH. So to the alkyl part of the ester, we're going to add H. And to the alkanoate part, we're going to add O negative Na plus. If we use potassium hydroxide to the acid part, we add O Na plus. We just do it like that because it doesn't form a covalent bond, so it wouldn't have a so KOH has 2 parts. The H goes to the alcohol portion, which is the alkyl portion, and the alkanate portion going at ONA. So here is an ester. And I react my ester with my NaOH. When I break the molecule here, this part is the alkanoate part, or the part from the acid. So to that part, I am going to add, what do I add over there? O, Na. And to the alcohol part, I'm going to add back the H. Clear? Hello?
Yes, yes.
Now I am reacting ethyl ethanoate with KOH. I'm going to split the molecule right here. So the first part I am going to add, which is the acid part, I am going to add OK. And to this part, I'm going to add H. So H is there. I have O, H, H, CH3 right there. Clear?